So, welcome to Math-Tinik. So, our next topic is all about ordinary differential equation, order 1, specifically exact equation. First, we will consider this one for an example. For an instance, we are given that m function of x comma y dx plus n function of x comma y dy is equals to 0. Considering this one, implicit, an implicit function, while this one also as an implicit function. While to solve our equation, considering that if partial derivative of m with respect to y, then considering x as a constant on our first term. So when we take the partial derivative of that and then taking the partial derivative of the other one, of this one, partial derivative of n with respect to x with y as a constant, then if two values are the same, then we can therefore conclude that this differential equation is exact. So to solve this one, we have a trick. Uh, to intake on the first term, we will consider this one as y as a constant. So integrating uh, function of m with respect to x dx, considering y as a constant, plus integral of n dy, where we will only integrate only pure y, then equals to c. To see this to see this tip, we have to consider example number 1. For example number 1, we have quantity x plus y dx plus quantity x minus y dy is equals to 0. First, taking the partial derivative, we will consider this one as our m, and we will consider this one as n. Then taking the partial derivative of m with respect to y, so taking the partial derivative, so as was constant, taking the partial derivative of this, so we will have x a constant, so 0, plus partial derivative of n of this one, which is 1. So taking the partial derivative of the second term, so partial derivative of n with respect to x, so considering y as a constant, we will have 0 sorry, 1 1 minus 0. We can see that partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So you can see we have, I'll just rewrite it first, quantity x plus y dx plus x minus y dy is equals to 0. We know that this equation is exact considering the partial derivatives. Then we'll go to integrate this one, where y is a constant, and then on the others on the other term we will consider integrating this one where pure y is only to be integrated. So now we will integrate. So we will have x multiplied by y. Sorry. Just delete it first. So considering this one, so we will have y 1/2 x squared plus xy plus, considering on the other side, we will only integrate pure y on the other side. So this one will become 0, and then we'll have quantity negative y squared over 2 is equals to c. So you can see we could multiply both sides by 2. So we will have x squared plus 2xy minus y squared is equals to c. So that's the answer. Then we will go to our second example. So we have this. um, Quantity y squared minus 2xy plus 6x dx minus x squared minus 2xy plus 2 dy is equals to 0. We know that in order to, we have this formula. So we have m dx plus n dy is equals to 0. Considering that we have a plus sign here. So first we have to distribute this one to this term. So we will have y squared minus 2xy plus 6x quantity dx plus quantity. I'll just distribute the negative sign. So we will have negative x squared plus 2xy minus 2 dy is equals to 0. So testing for exactness. So we will have, just move it. So we will testing for exactness. So this one as m and this one as n. Apologies. So considering this one as m and considering this one as n. So taking the partial derivative, so we will have partial derivative of m with respect to y. So we will have 2y minus the partial of derivative of this will become minus 2x. And then this one, because x is considering x as a constant, so this one will be 0. So on the other side, we will have partial derivative of n with respect to x, where y is equals to constant. So we will have negative 2x plus 2y. Oh, so this one will become 0 because it's just a constant. So as you can see, partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So therefore, we conclude that this equation is exact. So now let's go. I'll just rewrite it first. So we will have y squared minus 2xy plus 6 quantity dx plus quantity negative x squared plus 2xy minus 2 dy is equals to 0. So integrating both sides. So on the first term, we will consider y as a constant. And then on the other side, on the second term, we will only integrate pure y. So pure y only. So integrating our equation, so we will have x y squared minus 2x squared over 2 plus 6x. So on the second term, we will consider only pure y. So we will have, so this will cancel out. This also cancels out. So we will have minus 2y is equals to c. As you can see, simplifying further, we will have x y squared minus this will cancels out. So we will have minus x squared y plus 6x minus 2y is equals to c. So that's the answer. Now let's go to our third problem, third example. So as you can see, we will consider this one as m, then this one as n. So we will have by first taking the first partial derivative of m with respect to theta. So we will have, so this will become 0 plus the derivative of sine theta, which is equivalent to cosine theta, minus the derivative of cosine theta, which is negative sine theta. So simplifying further, so we will have partial derivative of m with respect to theta, that's delta, is equals to cosine theta plus sine theta. So on the other side, on the second term, so we will have partial derivative of n with respect to the opposite, which is r. So we will have, so derivative of r, which is equivalent to 1. So we will have sine theta plus derivative of r also. So we will have cosine theta plus cosine theta. Considering theta as a constant here, then considering uh, r as a constant here. So we will have, so further simplifying, we have partial derivative of n with respect to theta is equals to sine of theta plus cosine of theta. As you can see, our partial derivative is equal. Therefore, we conclude that this is an exact equation. So I'll just rewrite our problem. So we have just change the ink. So we have r plus sine theta, r plus sine theta minus cosine theta quantity dr plus quantity r sine theta plus r cosine theta d theta is equals to 0. So on the first term, we will consider theta as a constant. On the second term, integrating the second term, we will consider only pure, pure theta only. So we will have, so integrating with respect to dr, so we will have 1/2 r squared plus r sine theta minus r cosine theta plus, as you can see, do we have pure y, pure theta only? So as you can see, we don't have, so this will become 0, this will become 0. So we will have plus 0 is equals to c. So you can see, further simplifying our equation by multiplying it by 2. So we will have 2 r squared plus 2, sorry, we only have, we only have r squared plus 2 r sine theta minus 2 r cosine theta is equals to 2c. We know that we know that 2c is also equivalent to c. So we will just consider it as a c. So that's the answer. So thank you, Math-Tinik, and then see you on my next video.